is then a signal generator? A signal generator is an electronic device which generates electrical signals with given properties, like waveform, amplitude, frequency, etc. The number of parameters that you can select and configure depends on the product itself and the target use. In order to distinguish them, we can divide them in 3 categories. Of course, nowadays this division is harder to set as more options are available in different price categories, so it basically depends on how much you are willing to pay for given specifications. First, we have the function generator. You can generate basic functions like sine, sawtooth, square, and also with a limited set of parameters, most likely only amplitude, offset, and frequency, varying from a few hertz up to 3, perhaps 5 megahertz. Then we have the radio frequency generator. The distinction comes from the higher frequency that you can generate in the area of the hundreds of megahertz up to the gigahertz. The waveforms can be sine waves with modulation like AM, FM, etc. Lastly, we have the arbitrary waveform generators. They provide the highest flexibility, therefore arbitrary, in a wide frequency range. Nowadays, they are not so expensive and they are recommended if you are serious about electronics. As we saw what are they and what types you can find, what is the purpose? Why do we need them? Well, they belong to the test equipment category in electronics. That means you will use them to test the circuits that you developed in order to prove the real-life performance or maybe what you calculated or simulated. It could also be that you are repairing a device and there is no access to sensors or external signals that your circuit needs to function. Therefore, you can use the generator to feed the necessary signals into the device under test. Most signal generators have a display to show and interact with signal parameters, input as a keyboard or a wheel to configure these parameters, some front buttons to access the menu shortcuts, and some extra functions like a USB stick to download or upload waveforms. On the back panel, we also have some advanced options like LAN connection or a very precise fixed frequency signal. So how do we use a signal generator? First, we have to select the type of waveform that we need. As we can see at the bottom of the screen, we have many options like a sine, a square, a ramp, pulse, noise, and in this case we also have a DC voltage and the arbitrary option. But for this example, we're going to go back and use a sine. Then we press the parameters button. Among the parameters, we have to select the frequency or the period. Both are possible. Here we see that the actual shape of the waveform is on the left side of the screen with established parameters to the side. This generator has 2 channels, but we will be using only the channel 1. So let's select the frequency and let's give it a value of 100 kilohertz. Now we are selecting the amplitude. In this case, you can select it as voltage peak to peak or as a high level and low level as absolutes, which is the level in comparison to the 0 volts. So let's select now an amplitude of 10 volts peak to peak. As you can see, you also have the millivolt range with the RMS voltages. Then we can also establish an offset if we want, which is the offset versus ground or 0 volts reference. We're going to select 1 volt. Next step is the phase. The phase is the delay we have on the time axis. So just for the example, let's select 90 degrees. The harmonics is also an option, but this is more advanced and we're going to stick to the basics. So the other thing that we have to configure is the output. we can see that the load can be also configured. Therefore, we go to Utility, we select Output Setup, then Load, and then we select the high input impedance or also the 50 ohms. But also you can see this is not limited and we can select different values in between. For our case, we're going to use the high input impedance. And then we return to the parameters. As now we have everything configured, we see the output is off, which is something that I always recommend in order to avoid any problems in our circuit. So here we have the output signal with a 10 volts peak to peak and 100 kHz frequency. We can also see the 1 volt output offset. Of course, we can also change the parameters, for example a square wave with different frequency and amplitude. Here we have a ramp or a pulse to which we can change the duty cycle. Then we have the arbitrary waveforms, and for this the built-in ones are way too many. You can also upload your own ones through the USB stick. So now you have a wide comprehension of signal generators. I hope it was useful. See you next time.